We've already seen how we can find volumes of rotation and areas using the process of integration. In this video, we're basically going to be learning how integration can also be used to reverse differentiation. And it's done in a similar way to how we used to find areas and volumes, but with just tiny differences. So let's look at an example over here. So we know that if we have some equation y, then we can differentiate it and get dy by dx. And then we can differentiate it again and basically get the double derivative, or d squared y dx squared. Now what integration does is it basically allows us to reverse this. So you could integrate the double derivative and get the single derivative, and then integrate again and get the original equation back. So let's look at how we actually do this. If I have an example, let's say it's dy by dx. I just wrote that wrong. If this is dy by dx, and let's say this is equal to something, let's say x raised to the power 3, and we're supposed to find, and we're supposed to reverse this, right? We need to reverse this and get an equation in terms of an equation of y. So basically what we're going to do is we're going to integrate this. So we just grab this thing and we integrate it, and we basically know how to integrate this. And remember, over here you don't put your limits. Why? Because you usually put your limits in when you're trying to find the area or you're trying to find the volume of revolution. In this case, that is not our main objective. Our main objective is to reverse the process of differentiation, and so we don't use limits. So we know that this is going to integrate to x to the power 4 divided by 4. Now since we didn't add the limits, we're not going to put any limits over here either. So no limits over here. Instead, what we do is we add a constant of integration that we call plus c. And what is this plus c? I'll explain that in just a bit. So basically this is our equation now. This entire thing is our equation, and of course we were going to have our y over here because we just reversed this using integration. So that dy by dx, that slope equation, has now turned into an equation for y. Now what is this plus c right over here? Basically, if I just write some equations over here, let's say this is x to the power 2 plus 5, and then we have y is equal to x to the power 2, and then we have nothing with it, and so we have y is equal to x to the power 2 minus 10. And let's say I find the derivative of these. So I find the derivative of this equation is basically going to be 2x. Then I find the derivative of this equation, that's also going to be 2x. Then I find the derivative of this equation, and that is also going to be 2x. Okay, and now let's say I want to reverse this process of differentiation, and I want to get those things back. So what do? I know I can integrate all of this stuff. So when I integrate this, I'm going to get something, and that something is basically going to be, I'm just going to integrate this. So this is going to be something like this. We know that 2 is a coefficient, so we can drag it outside. That's going to be 2. And this is integral x dx. We know how to integrate this. It's basically going to be 2 times x to the power 2 over 2. Okay, so we can cancel out this, we can cancel out that, and we're left with x squared. And then in the same way, we're going to integrate this 2x, so this right here is y. We're going to integrate that, and we're going to get this equation, x squared. And then we can integrate this, and then again we're going to get this equation. Now you can see we've clearly lost those constants. So we know that this thing is not this thing. This thing actually coincidentally turns out to be this thing right over here, but we can clearly see this thing is not that thing. And over here we have this constant of 0, and we also have a constant of 0, and then we can kind of say that the constant is 0 in all of these. But that's not the point. Point is that these things, this and this, they are not this and this. They are not this and this. So we actually lose our constants. So that means that we need to do something to actually not lose our constants. And what we do is we basically, whenever we integrate, reversing differentiation, remember, when we don't add limits, see, we didn't add limits over here, we didn't add limits over here. In both of those processes, we were reversing differentiation. So whenever you're reversing differentiation, whenever you're using integration to reverse differentiation, and you do not add limits, you're always going to add a plus c. Remember that. That is very important. You cannot miss this plus c. And you can add this plus c over here, and over here. And how do you find the value of plus c? I know that in this case it's going to be -10. I know that in this case it's going to be 0. I know that in this case it's going to be +5. But how do I actually find that? Well, you have these equations. You have all of these equations. If you know what your y is, if you know, let's say for this equation, you know what your y is and you know what your x is, then you can basically make plus c the subject and find out the value of plus c. And you could do the same over here, you could do the same over here. So ideally, they'll basically give you sort of a point like this. Let's say that point is 5, 10. They're going to give you a point like that. Now that point has an x value and that point has a y value. You go ahead, you chuck the y value in here, you chuck the x value in here, and you find out what that plus c is. Now this is just some random point I assumed. In your exams and in proper questions, you're obviously going to be given points that aren't completely random and the right points. And so you are going to be given some point for this equation right over here. Maybe it's 2, 8. And maybe for this equation you have, let's say, 1, 0, something like that. Okay, so you just go ahead and you chuck these points in and you get that plus c, and that's how you get your constant back. But the idea is, whenever you're integrating, in order to reverse the process of differentiation, you got to add that plus c. Now in the same way, we can have a double derivative. Let's say that's d squared y dx squared. We could have a double derivative. Let's say that's equal to, I don't know, let's say that's equal to 2. And we're supposed to find out y, right? We're supposed to find out an equation for y. So how do we do that? Well, we know we can integrate this. So when we integrate this, we're basically going to get 2x. And remember, don't forget that plus c. I'm not showing the process of integration over here, but when you do it, you're going to get 2x. And then don't forget to add plus c, because we're reversing the process of differentiation. And then of course you're going to get your dy by dx over here. Why? Because you've integrated this once. You need to integrate this twice to get the equation for y. And so this time you actually need to know the slope. What is dy by dx? It's basically the slope at some point. So you basically need to know the slope of a curve at point x, and that x could be whatever. So let's say and if you have these two things, then you can go ahead and you can find the plus c over here. So how do you do that? Well, they're basically going to say that you have some curve and it has a slope of, let's say, 5 when x equals 3, right? Let's say they do that when x equals 3. So you just go ahead, you chuck that x over here, you chuck that slope over here, and then you can find that plus c. Once you have that plus c, let's say that plus c comes out to be, 8. Okay, so you have 2x plus 8, and then you have this thing right over here. Now you integrate it once more, and then when you integrate it once more, you're going to have another plus c. So it's going to be something like x squared plus 8x, and then that plus c is what you're going to add. And then you're obviously, this is going to be y, because you've integrated it once more. And then now you need a point. Now you're going to need a point, and that point is going to have some value of x. Let's say it has a value of x equals 3 and a value of y equals 15. So you chuck that x value in here and in here, and you chuck that y value in there, and you're going to find this plus c. And let's say that plus c comes out to be 20. So you're just going to write that the equation of y is equal to x squared plus 8x plus 20. So this plus c is very important. Don't forget that plus c. And remember that integration can actually be used to reverse the process of differentiation.